Good morning. Welcome to Anne Arundel Community College. My name is Jose Barata, and I'm the STEM coordinator here. And what I'm doing is trying to promote science, technology, engineering, and math. You know what STEM is, right? Now, in your school, you're probably not allowed to do this, but from now on, whenever I raise my hand, I want you to yell STEM so loud that the rest of your schools downstairs can hear you. Can you do that? Let's try it just once. I love it. I love it. I want you to learn 3 things today. Just 3 things. First, STEM is really, really important. This thing needs people that can design it and the apps for it. The clothes I wear were made out of things that people design. The chairs that you're sitting in, the cars, all the technology you use needs STEM. That's the first thing. STEM is important. STEM is important because we're going to need more ways to solve disease, to come up with food for the world, to clean up the environment. So that's the second thing you want to know. Everybody uses STEM as the first. Second is that it's important. What's the third? That everybody can do STEM. You. Y tú también. So what we can do is all of us here can study well in school and learn all those subjects.
That's
and then
better.
When you get here, third thing, since all of you can do STEM, you can come and study with people like Professor Foster, who can help you be the world's greatest user of all computer software in the world. Professor Lloyd, and learn about all those technologies that we use to solve people's health problems and help them stay healthy. Scientists like Professor Schrader and Professor Barber, that can teach you about the environment and about the human body. All these things, and all of you can become part of STEM. So, you're going to have fun with STEM! I hope to see you all here with your students. Thank you so much for coming.
All right, thank you.
All right, thank you very much for that wonderful introduction. Again, I'm Jason Barber. You can call me Dr. B. This is Greg Schrader. You can call him Dr. S. We teach here at Anne Arundel Community College. I teach physics and chemistry classes, and Dr. S teaches anatomy and physiology. Y'all are in 4th grade, right? I have a 4th grader at home, but I remember when I was in 4th grade, and I wasn't thinking about going to college. My parents didn't go to college, so it wasn't something I was thinking about, but I hope that you start to think about that as a possible path for you. Because for me, I had some people that encouraged me to do that, and it allowed me to get this wonderful job. And so I hope that you have people that are encouraging you, and I'm starting to encourage you to go to college. It's a great, it opens a lot of doors for you. Dr. S had a little bit of different experience.
So when I was younger, most folks told me that I couldn't go to college. I wasn't able to do it. I wasn't smart enough. And that carried on for a long time until one person said, hey, just go and take one class. See how you do. And I ended up doing okay. They helped me through it, and years later, I ended up getting my PhD. Crazy. You know why? Someone helped me, and I found something I loved. Then I didn't have to go to college. I actually wanted to. I wanted to learn more because it was so much fun. So I encourage you to go find something that you really enjoy, and who knows, maybe you'll be up here doing the same thing I'm doing one day, which would be kind of cool. Very exciting.
All right, so we're just about to get started. Y'all are being so good. I love it. We're going to do some demonstrations. They're hopefully going to be pretty interesting and exciting for you. And some of them might look like magic, but I assure you none of them are magic. We want you to understand everything we do. We want you to be curious. Go home, try out some of these things. We want you to be interested and try to find out more. Now, if you're going to try out anything at home, first thing you should do, get an adult to help you. Get your parents' permission. Get an adult to work with you. Okay, that's the most important thing because we want you to be safe. If it involves a stove or a lighter or matches, definitely, absolutely have to have a parent there at all times. All right? So are y'all excited? You ready to get started?
Yeah. I'm ready to get started.
All right.
Well, these things are in the way. Should we just get rid of these things? Okay, yeah, this is right.
What are these anyway?
I don't know. Just... There it goes. I don't know where that one went. That was a mystery. Well, all right, since we're on the theme of balloons, I'm going to ask Dr. B to do something very simple for me. I'd like you just to blow up this balloon for me. Could you do that, please?
Sure, I have lots of
Thank you.
experience in that area.
Okay. Just blow it up. Come on. Can you just blow it up? I know you're full of a lot of hot air. You can do this, right? Oh, wait. Oh, that's me. Sorry.
Can't do it.
Oh, are you
Well,
sure?
working.
You know, that seems really hard, doesn't it? Yeah. You know, what if I just take this thing out? It's in the way anyway. So go ahead and give it a try with that. Ah. Well, that's interesting. I wonder what happened. Well, when Dr. B tried to blow this up with the cork in it, what's inside of this glass ball? Air, right? So there's air pushing on the balloon, so he tries to put air in the balloon, and the balloon can't blow up. There's too much air around it. So what happened when I took this out? The air could escape, and then the balloon could grow with his air in it, right? Which he has plenty of, by the way. All right, so you want to see something cool? Watch. So blow this up. Now watch what happens when I put the cork back in. All right? Oh, isn't that
It's totally
interesting?
open on the front.
So that's interesting. Now, to explain that, you're going to have to come to college, right? Right? It's a pretty cool concept, but what I personally like that one because I like balloons. But you know what else I like? I like air. Who likes air? You like? I'm glad you like air. So you all seem to like it so much. I'm sure you're experts in air, aren't you? So what is air? What is in air? Oh, so we got so oxygen, what else? We got oxygen. Anything else in the air? H2O, a little bit. Actually, there is a little bit of H2O in there. What else? Anyone else? What do you think?
Carbon dioxide.
Vapor? Not yet.
Keep you alive.
It does keep you alive. It's important. Did you know that there's nitrogen in the air?
Oh yeah.
Yeah, there's nitrogen. Whoa, Dr. B's really getting carried away with that one, right? Does anyone know what comes out of our mouth besides noise? Carbon dioxide, right, that's in the air too. So all these different gases make up air. Did you notice that he didn't write them the same size? He wrote the nitrogen really big. His big hat's in the way, but he's getting out of the way right now. So look, nitrogen, the N, is huge because most of the air around here is made up of nitrogen. It's over 70% is made up of nitrogen. And then the next one is oxygen because we like that one, right? But the rest of them, very little bit of those gases in the air. So there's tons of gases that make up the air. When we think of air being really light, don't we? Like it's not heavy. Well, we're going to do a couple of demonstrations that might help us figure out if air is really light.
All right, now I need those students that are over here. You have card 1 and card 2. Come on up.
Come on down.
All right, so let's see. Come on over to here. Yeah, you can wait right there. And what is your name? Esther? All right, Esther. Here, I'll take that from you. Thank you so much. All right, so I have this mat here, okay?
Oh.
And it's just a rubber mat. And I just want you to just lift it with one hand right there on the handle. Just lift it right off the stool, okay? All right, so just grab it by the handle with one hand.
Now, it's like a slide, so
See,
Dr. B is going to put his hands there.
I'm not holding the mat down, am I? Okay, I just want you to lift it. Go ahead, lift. Lift. Go ahead, lift. Stronger.
Just the mat.
Keep going.
just
All right, use
the-
2 hands.
Just the mat. Just the
You're
mat.
lifting the whole stool.
What?
Go ahead, lift.
Come on. Get that. It can't be
Okay,
that.
all right, hold
okay.
on.
Now let's see.
Oh, that was good. That was good.
That was good.
Okay, so that's kind of weird.
That's kind of weird.
Dr. S,
Let me see this thing.
tell us what's going on with that.
Let me.
Thank you very
let me-
much, Esther.
Let me see. You know, so I don't need this thing. Let me go back here. See. Thank you. Man, I gotta use both hands with this thing. It's so heavy. What did you put in this thing? All right. Oh goodness, this thing. I think I broke my finger. We have another volunteer.
Yes.
What is your name? Marvin. Thank you, Marvin, for volunteering. I'll take that card. Marvin, I heard you ate your Wheaties this morning, did you? That means he's big and strong, and his spinach. So I want you to give it a try, okay? So I'm going to make sure it doesn't slide here. You just go and pick it up. Here, let's what did you, how in the world? Hold on. Man, can you make a muscle? That is incredible. Can you do that again one more time? What? Whoa. What is going on, Mark? You know what? Wait a minute. Something's going on here. You know what? You can go have a seat, and I'm going to explain what's happening here because it's science, believe it or not.
All right, big round of applause for our volunteers.
Thank you. So, this is just a plain old rubber mat, no well, that's a wood stool anyway, but no magnets, just a plain rubber mat. And we talked about air being all around us, right? Well, did you know that for every square inch, there is 15 pounds of force from the air around us? So how big is a square inch? That big. That's a square inch. So this mat, how many of these do you think we have that would fill this mat up? Well, I'll tell you. It's 7 inches by 7 inches. So you get to tell me I didn't even get to ask you. You already told me. You guys are awesome. 7 times 7 is 49. So there's 49 square inches. And for every square inch, how many pounds? 15. So 49 times 15 is over 700 pounds of force from the air pushing down on that mat. That's crazy, isn't it? So then how come Martin could just pick it up with no problem? Well, because I kind of cheated a little bit. I took this pen and I stuck it on here so that when I put the mat down, now there's air underneath the mat and on top. So I got the same amount of force pushing on both sides, so then the only thing Martin had to lift up was the weight of the mat, which really isn't heavy at all. Marvin? Well, Martin, that's his superhero name, Martin. Sorry. Marvin, thank you. Marvin was able to pick this up with very little effort. But isn't that amazing? 15 pounds. That's a lot, right, per square inch. So we're going to move on to something exciting, right? So he likes this thing, you know. I just can't help it. What? We got to keep moving there, buddy.
Okay, I think we're done with that.
I'll take this away.
Get rid of the mat. Now I have a question.
For Dr. S. What was that question I was going to ask him? I can't remember. Let me sit down and think about it for a minute. Oh, sorry. Dr. S, I said to take the mat off the stool. They came as a package. Oh. All right. Thank you. All right. So where was I? Oh, the question. So we have some volunteers with cars 3, 4, 5, and 6. Come on, Mike. Just wait right here. If you could just wait right there on the steps. All right, just right there. We'll be with you. I remember the question Dr. asked.
You have a question for me?
All right.
I love questions. They call me Mr. Answer.
All right. So you said there's air in this room, right?
Yes.
Okay. What I want to know is how many air molecules are there in the whole room?
Oh, I got this. Give me a hard one, please. Okay.
1,000. What do you think? That sound about right? Or higher? Yeah, definitely higher, Dr. Mouse.
Higher? All right. Oh, you know what? I'm going to take care of this. No problem.
1 million. Does that sound about right? Higher.
Well, I'm going
Higher,
to...
Dr. S. All right. Let's get our volunteers. Come on up.
All right. We're going to take care of this.
All right. I'll take your card from you.
No problem.
All right.
All right, I need one person. Come on over here. Okay, you're going to hold this right here. Stand right behind you. And just hold this up. Because that's going to take care of it. We're good, thanks. You're awesome.
One trillion. Here, step back out of the way so that these folks can see. All right, 1 trillion. That's still way too low, Dr. S.
I'm going to run it. All right, we're going to take care of this. I'm highly confident. This one's the one. All right, we're going to take care of the mat. Come on over here. Stand right here.
Come on, Dr. S. Keep going.
This is crazy. All right, come on. Hold this stuff. This has got to stop. I need a break. I'm all zeroed out.
octillion, I think it is. Correct me if I'm wrong. With a 1 and 30 zeros. Wow, that's how many air molecules are in the room. Not only that, but the air molecules are moving around. We don't notice that they're moving around, but the average air molecule is moving around at about 1,000 miles per hour. And they're running into each other, so they don't move very far. They run into each other, they run into the table, the floor, that black pressure mat. Oh, now we can start to understand a little better that black mat. There's that many air molecules in here, and they're running into the mat really fast, and that's what holds it down. And so if there's no air underneath, that makes quite a big force holding it down. All right, thanks to our volunteers.
All right.
And now we
need our teacher volunteers. A little demonstration called magnetic water. So you're going to have a cup. You're going to have a cup. You're going to have a cardboard. This is a piece of cardboard. It's just like the kind you would find in a cereal box. Right? So it's not hard to find. You just get a cereal box, cut it, you get a little piece like this. So what we're going to do, and I'll demonstrate with you, is you're going to take the cardboard cup, cardboard on top, make sure it's covered. You're going to turn it over and let go. That's not very exciting. Okay. What would happen if I put water inside the cup? And I put this on there and then we turn it upside down and let go. Well, you know what? We don't have to wonder. We're going to actually see it. And here's the best part. It's going to be over top Dr. B and my fist. Alright, so I'm pouring real water, not fake. Oh boy. That's Dr. B. Okay. Is there anything sticky on top of this cup? I don't think so. How about the paper? Not that I can tell. Okay. So, I'm going to pour some water here for me. That's good. Let's all go a little more. Alright, so. Oh, thanks. Now, yours is more. Alright. No. Alright, is there anything sticky? Now, how about on the cardboard? Nothing sticky? Alright, so what we're going to do, not like we're going to get wet or anything, because this is science, and science never goes wrong, right? He said it was going to work. Oh, that's what I'm talking about. Yes. Alright, what you want? So, we're just going to sit down here, and you're going to do that very thing with putting that cardboard on top and then turning it over, and then you're going to let go right over top of our heads when I say 1, 2, 3. But not yet. Hold on. Are you ready? Technical difficulties. You got a big towel. All right, here we go. All right, ready? 1, 2, 3. Uh-oh. All right. I'm glad you didn't get wet. I'm glad you didn't get wet, buddy, because it's awful. Take your hand out. Take your hand out. Okay. Is that good? All right. Well, hey, let's just thank these teachers for not getting us wet, because that would be really awful if I was wet. Thank you very much. All right. That was awesome if you like getting wet. Boy, I wish it was sunny and 90 degrees out, because that would felt really good. But it's not. Wow, I think we got a little floor wet. Thanks, Dr. F. Anytime I'm here for you. Alright, so I think we missed a spot, maybe. Yep, I think it's all covered.
So it did work, right? Let's show it again. Right? Because it did work, right? The teachers, they moved their hands out and it worked. So let me just show you again. So we put water in there, we put this card on there, flip it over. And what happens when I let go of this card in a minute, the water is going to fall just a little bit. And you won't notice it, but it is going to fall just a little bit. But when it does that, the air pressure inside of here is going to decrease. And then what's going to happen to the air pressure out here? Nothing. Nothing. It's just going to stay the same. Okay? 15 pounds per square inch, a little bit less than 15. And let's see if that holds it in place. There we go. Just like before. So low pressure, regular pressure. And then if I pull the card out, wait a minute. Oh, some water came out and some didn't. That's kind of weird. Just do that again. Hold on.
That can't be. I gotta see that again.
All right. Let's try that again. All right. All right.
That is bizarre.
There is something over it, but look, it still comes out. All right. All right. So there's a metal screen there.
Yeah.
Okay. So this was different. When the teachers were doing it, they just used regular old cups. And it works with that. You saw it work with that. I did an extra level on there, so I added this piece of screen. And so when it was upside down, sure, air pressure was holding it in. I removed that. We still had to have air pressure to hold it in. But then we had this other property of water that was helping to hold it in as well. And that's the surface tension of the water. Water molecules, there's trillions and trillions of water molecules in there. Well, they all kind of hold hands with each other. There's a special kind of bonding where they all hold on to each other. And that gives the surface. Sorry. Thank you. Thank you for that. Yes, I appreciate that.
Sorry, bonding. Sorry.
So they all hold on to each other, and that's called surface tension. Now, you may have noticed this. Perhaps, has anybody ever seen insects, bugs that can stand on top of the water and move around? They can do that because of surface tension. Or if you've ever been filling up a cup of water and you get it a little too full, you're pouring, you go, oh, and it gets a little too full and it goes up over the top, that's because of surface tension. And that's what was allowing the water to stay in place when I had it upside down. Okay, that plus the air pressure. So what do you think, kids? Are these things you could try at home? Yeah, absolutely. These are nice, safe things to do. Talk to your parents, find out where they want you to do it. Maybe over the sink.
Maybe over their head.
Maybe outside would be a good place.
Let's do that out there.
All right.
So I'm excited.
Dr. S.
Yes.
I have here a hard-boiled egg.
Oh, good. I'm hungry. Thanks for that.
For lunch.
I'm sorry.
All right. So I have here a hard-boiled egg.
Quick thinking.
Yes. Just didn't feel the same.
Yes. I was getting lightheaded. That's funny somewhere. Okay.
It's been peeled, so it's nice and squishy. And I just want you to just put it into the bottle without breaking it.
All right. Let's see if I can. This is just put the egg in the bottle.
Put the egg in the bottle.
No.
Don't break the egg.
No. All right. I can do this. With.
Dr. S, you done? You got it?
Almost. This is not.
Wait, get it out of here. Let me show you. So you just push and no, it's not working. Oh. So as soon as we try to push on it, oh, this is like that balloon thing we did at the beginning.
Yeah.
As soon as we try to push, it increases the air pressure in here, and the further I push, the greater the air pressure, and so it just gets harder and harder to do, and it's impossible. I think that's impossible to do without breaking it. All right. So
Well, we tried.
let's try something else instead.
Okay.
Let's heat up the air inside the bottle. I think if we heat up the air inside the bottle, the air will expand and it'll push the egg off the bottle and
that'll be.
we'll try. So here we go. Let's try this.
Oh,
So I'm going to heat it up by lighting this paper on fire. Let's see. Remember, always have an adult to help you.
So Dr. B was right. We saw fire heat up the air. They tried to push the egg off, it was bouncing, but it didn't have enough pressure to push it off. But then when the fire went out, the air inside rapidly cooled down, and it lowered the pressure inside of here, so that the pressure in here was lower than the pressure out here. So the force out here pushed that egg right into this thing. Wasn't that cool? So we used a little bit of science to get that egg in there. That was fun. I can say I wouldn't eat that egg right now.
All right, thank you, Dr. S. So we're learning about air pressure. Have you all enjoyed learning about air pressure? Some pretty interesting things that air pressure can do. And that one, you can even try that one at home if you have a parent or a responsible adult to help you. All right, now, so to make sure that you understand what we've been talking about with respect to air pressure, we have a little homework assignment for you. It's really fun, okay? We're going to give you a piece of paper and you're going to get a little backpack at the end of the day. It's going to have one piece of paper that will explain how to do this homework assignment. We're going to show you how to do it right here. So we're giving you the answer. It's really easy homework. And you get to show this to somebody that you know, like your parents or I don't know, somebody. All right, so the first step is to find a responsible adult to help you out. All right, not this guy. All right, second step, find a soda can, an empty one, put a little bit of water in it.
Yeah.
All these instructions are written down for you. Put a little bit of water in the bottom, have your adult heat it on the stove for you, get it going nice, boiling really well. Are these boiling, Dr. S? Oh, I hope so.
They are. They're steaming.
All right, so you wait till the steam is coming out the top. And if this doesn't work, that just means you're going to have to try it at home.
Yeah.
Oh, wait, you're going to try it at home anyway. Ready? So you wait till it's steaming, and then you have your adult helper grab the can with some tongs, put it into a bowl of cool water.
And that didn't work.
And remember, I saw it wasn't steaming.
I know.
I didn't see any steam, did you?
I don't know. Do we both use?
It's still on. All
All
right.
Yeah, let me know.
So
It feels hot.
here we go. That was an important observation.
That's right. We're showing you what it
When
looks
you-
like when it doesn't work.
When you do investigations, when you're trying things out, you're trying to learn more, you're going to try things, and sometimes they're not going to work like you expect them to. And what do you do then? Well, you learn something from them. And what I learned is if you can't see steam coming out the top,
It's probably
not going to work. All right? But I'll just show you one more time so you'll know how to tell your adult helper what to do, okay? And then this is going to make you even more curious to try this at home, okay? You ready? Just like that. All right? So you just have to flip it over right away. And then what do you think will happen?
Well, maybe
Hopefully something interesting.
maybe before the end of the show, we could show you what it looks like.
All right,
I'm
so what was
determined.
inside the can? We had water and air, and then the water boiled, and it made steam inside the can. Well, at least that's what it was supposed to happen. All right. Make steam inside the can. If you have a bunch of steam inside the can, and you put it into cool water, the steam will condense. And then it won't be taking up much space, and it won't be pushing on the inside of the can. So the pressure inside the can will go down, and if the pressure inside the can is low, and the pressure out here, remember, how big is the pressure out here? Fifth. That was a different. That's good. That's how many air molecules are in the room. Good. 15 pounds per square inch. So if the pressure out here is 15 and inside the can's a little less, what do you think would happen? Oh, is it going to explode or crush in?
What do you think?
It's going to crush in. All right.
Well, hopefully we'll get to see that.
You get to try that. All right. What do we have next?
Well, I have something. We've been talking about what kind of pressure? Air, right? So, talking about air pressure too much isn't really good for me. So, we're going to talk about a different kind of pressure. And we're going to use this bed of nails. How's that sound? Yeah, I think so. Yep. Because it's not coming out there. Yep. There it goes. Like that. Alright. There we go. Nice little bed of nails. So, let's see. We'll put it down here. Now, so So Dr. B and I made this bed of nails, and I wonder if it would be a good idea for me to just lay down this thing. Alright, so, well, we gotta make sure they're real nails, right? So this is an apple, right? And it has skin on it, so this could be my head, okay? So if I just want... Wait. Oh boy. Well, you know, apples have pretty thin skin, so maybe I'll try one of these things, you know, they're fun. A little balloon here, right? Let's see. This is a little bit thicker, right? So, I don't think this, I mean, it's not going to pop this because that's, you know, maybe, is it going to work? So, without laying on the bed of nails, I think I'm going to, Dr. B! Hey, Dr. B! Hey, thank you so much for volunteering to lay on the bed of nails. You're such a nice person. I am so thankful that you said yes. Thank you so much. So, Dr. B volunteered to lay on the bed of nails because he loves you guys so much. He's just going to do it without any questioning, right? Okay, so go ahead. Put your hands up. Oh, yeah, there you go. Wait a minute. It worked. I mean, yay. We knew it was going to work, right? We knew that was going to work. All right. So, how you going down there? Good. All right, let's get you back up there. Thank you, Dr. B. All right, so the balloon pop. I have a holy apple. Yet, Dr. B. So last time I put this balloon on a nail, and what happened to it? It popped. Let's try something else. Let's try. I'm okay. All right, so now I'm going to put it in the center of the bed nails, and let's see what happens if I just. No, see? All right. I'll put a book on top of here. Let's just see if we put a book on top of here. Oh, wow, big one. If anyone ever told you that you can't learn something from a textbook, they're wrong. We're going to tell you that today. All right, let's say, okay, well, hold the book. That's a biology book, too. Wow. All right, let's do another one. Think you can hold two books? All right, that's an A people. 3 college textbooks. Are you kidding me? This is crazy. You gonna do another one? All right, let's see what you got. 4 college textbooks. Think? It's not warming up. All right, let's try another one. All right, 5. Let's keep going. This is crazy. 5. 6. That's chemistry. Forget about it. All right, keep it coming. How about some nutrition? Nutrition? Nice. Really? Oh my God! Are we gonna run out? Let's see. 9 college textbooks to pop a balloon. How is that? Well, I'll tell you. So, pressure, that's right. So, when I popped the balloon the first time, I had all the pressure on one nail. But this time, I spread out the balloon over many nails, so that the pressure on each nail wasn't pushing that hard. That's why Dr. B could lay down there and he spread out his weight. There's 1,000 nails here. Yeah, the first time we did it, we did 500, and that's uncomfortable. So we did 1,000 nails, so that means for every square inch, there's a lot of nails. So not at any point is one nail pushing up really hard, or a lot of pressure pushing down on that one nail at any given point. So that's kind of nice. All right, so you can get on one end and I'll take the other end. We're going to take this up out here. Well, as you can imagine, you still have to be very careful. Now, this isn't something you can do at home, but I do have a way you can illustrate this at home, and it's real easy. You ever seen those little plastic cups? They're real small, right? They're about 8 ounces. You get a bunch of those, and you give about 30 of them to your friends. And you get a piece of wooden board, and you tell them that to lay down the cups on the floor, put the board on top, and you can stand on the board without crushing the cups. As long as you spread out the cups enough. So there can be a little test you can do with your friends. You give each friend 30 cups and say, lay them out, so when I put the board on top and I you can get your parents to stand on it, one of your parents to stand on it. Because it helped me, and whatever. It's kind of fun to do at home, and all you use is some plastic cups and a wooden board. It's kind of fun. All right. Yeah. You got it. Watch this right here. That's crazy. It's pretty amazing here, right? So, pretty crazy that it was holding it in place when it was bent over that far. And so we can try to explain this using something called Bernoulli's principle. Hey, I know Bernoulli. Hey, I know Bernoulli. He makes that spaghetti sauce, right? It's really good. It's got the... No, that's a different guy. Oh. Go read some of those textbooks. Okay, I got it. All right. So as I was saying, Bernoulli's principle said that as the speed of a fluid increases, the pressure decreases. Oh. All right, so first of all, fluid. What's a fluid? Well, that's any liquid or gas. And the fluid we've been talking about all day is what fluid? Air, you got it. All right, good. So, but we do classify air as a fluid. We do. All right. So as the speed of the air increases, its pressure decreases. And that's kind of the opposite of what you might expect it to do. All right? And that one's fun to do, and you can try that if you have a vacuum cleaner where you can hook it up so it blows air out. That one you can try it out. But here's one that you could definitely do, and I think you'll be able to trick your friends with this one. So go home, 2 empty soda cans, a whole bunch of straws, and I like using the little ones, but the big ones will work too. And the straws just allow you to put these soda cans on the table, and they slide back and forth easily. All right? So now, I want you to predict, using Bernoulli's principle, I'm going to blow between the cans. Okay, so I'm going to blow right here, in between the cans. I want you to predict, how many people think when I blow right there, I'm going to lean over and blow right there. How many people think the cans are going to go apart? How many people think the cans are going to go together? Uh-oh. How many people think nothing's going to happen? Dr. Ash, you can't vote for all of them.
Well, I'm going to get it right on.
And we had a lot of people out there that didn't vote for any of them. So you do have to vote for one of those choices. All right, how many people say they'll go apart? Together? Nothing. All right, so let's try. Here we go. Oh, I was right. They go together. Wow. So what's going on there? Bernoulli's principle said as the speed of the air increases, the pressure will decrease.
before I did anything, air pressure here, and here was all 15 pounds per square inch. Then when I moved here, the air pressure here went down a little bit. Because it was going faster moving air here, so the pressure went down. Just regular old 15 pounds per square inch here. Pushed them together. All right. I think that's it for Bernoulli. Did you want to do that other Bernoulli?
I got something here.
We could do one more Bernoulli experiment. This is going to be a little loud, and I need you to stay in your seats, okay? So just stay in your seat. And, all right. So let's see if this will work.
Here we go. So, just because we like this next one, it has nothing to do with pressure, but it's a lot of fun. It's called elephant toothpaste. And, who doesn't love to see how elephants brush their teeth, right? So, in this demonstration, we're going to use hydrogen peroxide. It's called H2O2. Not to be confused with H2O, right? H2O is water. This is hydrogen peroxide. And hydrogen peroxide will break down into water and O2, which is what we're going to show you. But it takes a long time. So we're gonna add something called a catalyst. A catalyst is something that you put into a reaction that makes it go faster, but doesn't get used up itself. We're going to use potassium iodide as our catalyst. So we're going to mix potassium iodide with the hydrogen peroxide to get it to break down a little bit faster. Now you know it's a good demonstration when you have to roll out a drop cloth, right? Doesn't that always tell you it's a good demonstration when you have to roll out one of these? Yeah? That's why we marked off the spots right there. Alright, so we're going to get ready to do this demonstration. It's a lot of fun, and we can... Now, hey, let me talk about this hydrogen peroxide. The one that we're using today is really concentrated, 30% volume, so it's pretty concentrated. It'll burn your skin. So we're going to be safe and wear goggles and gloves, right? So goggles. Sorry, got to go. There we go. Hey, how do you put these? Okay. I always get my pinky and my thumb mixed up. And it's always hard to get this one. Here, what I'm going to do. Got an idea, right? Turkey time. Turkey time. Good thing I'm not doing emergency surgery. I got this. Okay, we're almost ready? Thank you. Doctor,
I think we're ready.
I thought we were using the big one.
No, I think these are the half-liter ones, right? These are the ones you wanted?
Hold on.
The bigger? I don't know what bigger one he's talking about. Where'd you go?
Oh, I think I got something better. What do you think about this?
Alright. So, here we go. So we're going to take the hydrogen peroxide, we put some dish soap and some food coloring in there, Now we're going to add the catalyst, and we're going to see the hydrogen peroxide turn into water vapor and oxygen. Ready? 1, 2, 3. You don't want to see this one, do you? You don't want to see this one? Thank you so much. We're so glad that you all got the chance to come here. We have a lot of fun stuff. Thank you. All right, you have some more fun activities to do downstairs. You're gonna get. It's not bad. You're gonna get to do some more fun stuff downstairs. You're gonna do hands-on stuff. So I need you to quietly stand up and move over to this aisle.